Want to talk about MCB rating calculation. This is an area that most of the electricians or electrical engineers miss out when carrying out electrical installation works. How do they miss it out? Most of us have got the theory behind it that maybe C32 is meant for maybe shower or cooker, something of that kind. And maybe C20 is for sockets, C16 for maybe high consumption lights, or C10 for general lights. But when we are doing this way, we are doing it the wrong way, meaning we are missing out on something according to the standard sets for electrical installation, that is Energy Regulations Act 2019. So I just want us to know and take you through how we calculate the correct MCB rating, so that whenever you are carrying out an electrical installation, you don't miss out or you don't do it the wrong way again. So just to start, we have something called diversity factor. What is a diversity factor? Diversity factor is the condition or assumption that all the loads are running at the same time and at their optimum level. Or in other terms, we can say that a diversity factor is the worst case scenario that uh, our load or appliances are running at the same time. So before we calculate the MCB calculation, rating calculation, we have to know the diversity factor. According to the standards, it is set as at 0.8. So we should always use a diversity factor of 0.8. This is a scenario that, or the worst case scenario, that our load or appliances are running at their peak and at the same time. After knowing the diversity factor, we have to know something on the power rating of the appliances or the load. For example, when we are told that we have an instant shower of 5,400, then the first thing we need to know, we need to calculate the current that this instant shower can carry. Then we can calculate our way out from there. So to calculate the current of our instant shower of 5,400 watts, we are going to have the power rating. We divide by the feed line voltage. Maybe some of you may be asking of what the feed line voltage is. Feed line voltage is just the incoming voltage from the meter, or the AC voltage that you are always supplied with from the energy meter. So that in Kenya we normally use appliances that operate on a 240 volt feed line, meaning our feed line will always range between 220 to 250 maximum. But the rated, or the ones that we normally use, is always 240 volts. So to calculate the current, we are going to take rated our rated power, which is 5,400, we divide by 240. Then if we do that, we are going to get an answer of 22.5 amps. Then now here is where the issue of diversity factor comes in. We have to calculate that maybe I have got this instant shower and it is running at its optimum peak. So to calculate the rating, then I'll need to have the current that we have calculated. We are going to divide it by the diversity factor, which is taking 22.5 amps, we divide by 0.8, which is our diversity factor. Then from this point, we are going to get the rating of 28.15 amps. But because there is no MCB rated 28.125, we are going to go to the immediate next higher MCB rating. This again is going to help us in something called accommodating startup current of the appliance or startup surge that may occur when we are starting our appliances. So the next immediate MCB is 32 amps, of which if we use that, it is going to accommodate the load, and our appliance can always run at its optimum peak. Let us look on maybe a second example. Let's say we have got 20 amps LED bulbs, 20 amps LED bulbs, and the number of these bulbs that we have in a house are maybe we have got as 5 bulbs. So here we are going to have to get our power rating. We are going to calculate power rating to be 20. Then we are going to multiply by the quantity or the number of bulbs that we have in that building. That is, we have 5 bulbs. So if we do this, we are going to get a total of 100 amps. Then now, let's say this, we have a circuit, one single circuit that is controlling these 520 amps bulbs, of which that brings a total amperage to 100 amps. So to calculate the current here, we are going to take 100 amps. We need to divide that one by 240. Then whatever we get there is going to be, we are going to get there 100. We divide by 240. Then if we divide that, we get it to be 0. We are going to get it to be 0.4166 amps. Then we now need to bring the factor of the diversity factor. Our diversity factor, we have it there to be 0.8. So we are going to take the value that we have obtained there, 0.4166 amps. Then we are going to divide it by 0.8 to get the correct MCB that can accommodate all our lights operating at optimum level. So if we take that, we are just going to divide it by 0.8. Then I'm getting an answer of 0.52 amps. And because there is no MCB rating rated 0.5 amps, we are going to go to the next MCB rating that can comfortably accommodate this load. So with this one, it means that our immediate next MCB is going to be equals to 1 amp. So you see, like in calculating this, we have omitted that theory of like using 10 amps for lights, meaning if we use 10 amps for this lighting, then it means that whenever there is a short circuit, then the whole of the circuit can be destroyed, or it can cause fire before the MCB can trip. But when we use 1 amp MCB, then it will always accommodate and function or operate the way it's needed, in that when there is any fault or short circuit within this line, then it will always trip within the required time. Let's take another scenario or another example. Let's say we are having a cooker. We have a cooker oven that is rated, let's say 5,600 watts. Then we want to know the correct MCB to use at this point. So we are just going to take 5,600, we divide by 240. Then this is going to give us a value like, let me just do the calculation. This is going to give us we have 5,600, we divide by 240, then this is going to give us 23.333. Then now to bring the issue of diversity factor, we are going to take our 23.333, we divide by 0.8. So our answer that we got there, we are just going to divide it by 0.8. Then we are going to get a value like 29 point. We have 29.166, and because there is no MCB rated at 29, we are going to go to the next immediate MCB so that we protect the startup current and the startup surge. So this implies that we are going to go to an MCB rating rated 32 amps. So that is basically how we calculate MCB rating during the process of our electrical installation. Hope you have learned something, and I hope you enjoyed. Always keep tuned for more and more skills on electrical and solar installation. Thank you.